Alright, kiddos, here we go.
Second time the charm.
Sequence, list of numbers written in explicit order. If they give me that formula, C sub n, actually, you know what, in pre-cal, it would probably be A sub n, to be honest. What does n stand for?
Number, right?
Any number? So how about 1.5? That makes total sense. Integers, why?
Whole number is fine.
Because it's the number of the term that you're looking for.
It's commonly the number of the term. Sometimes it's one lower or one higher, to be honest. Sometimes we start at 0 as the first term. Sometimes we start at 1 for the first time, for the first term. So starting at 0 or starting at 1, those are typically the starting points, but then we go by integers, by whole numbers only. So, if it says find the first 6 terms, man, I felt that coming. The first 6 terms, and if n is specifically in this example standing for the number of the term, which term? First n is 1, second n is 2, third n is 3. How do I find the first 6 terms?
You just plug it in.
Yeah, exactly. So therefore, the first one would end up being 1 plus 1 over 1 is 1.
2.
Sorry, 1 plus 1 over 1, 1, 1 plus 1 is 2, and 2 to the 1, right? Okay, what would the second term be?
1.5.
Separate by commas. This is not a series, not an expanding sum. It's just a sequence of terms. So separate, the second term would be separate by comma.
1.5 squared.
1 plus 1 over 2 is 1/2, raised to the second power, which would end up being a couple ways of doing it. You could say 1.5 squared, that's gross. You could say 3/2 squared. You could say 9/4. Technically the term itself would be 9/4, right? What would the third term be?
1
1
plus
plus
1
1 over 3.
third.
All to the-
16 ninths, right?
Third, that's right. That's right.
So we go ahead and do 3 over 3, so that's 4/3 raised to the third power, which would be 64/27. But, oh, can I simplify?
Yeah.
Yeah, you can. You can divide by 3.
Nope.
No, you cannot. 1 cannot.
No, yeah. Divide by 9? Nope. Hey, guess what? I think we're done, right?
Well, how's it the first 3 terms? I mean, 6 terms.
No, I mean, we're done with the 64/27s.
Oh.
Well,
That's only 3.
Okay, fourth term.
This is just getting weird.
5
5/4 to the fourth power.
625.
625.
64.
4 to the 4?
16, 64, 256, right?
Yeah, 16 times 16. Oh, yeah.
That's what you need to calculate.
Yeah.
What is it?
You don't
How
need-
nasty is this?
Well, it didn't start out that way. At about 4. That's
Okay, is there any other simpler way?
Yes, there's no way we're supposed to do 100 of these.
What do you mean 100 of these?
It's just find the first 6.
Pause. Do we need to find 99 to find the 100th?
No?
No, because what kind of formula is this? Explicit or implicit?
Explicit.
Which means to find the 100th, we're going to go ahead and cut it short just for sake of time. To find the 100th, we would just go ahead and do what? Plug in 1 plus,
Alright, 100 to the 100th power.
Oh, it's an overflow.
we'll just leave it. Yeah, it's too big. 1 plus 1 over 100 to the 100th power. We don't have to find all of them to get there. Now, yes, they said find the first 6 terms. Basically, we just got lazy and stopped. However, the explicit formula, what's nice about it?
You just have to plug
You
these
can plug
in.
in.
If they say find the 20th, plug in 20. If they say find the 57th, plug in the 57. If they say plug in 100, we plug in 100. We don't have to jump to get there. Now, question. Defined implicitly. Do you remember the difference?
that depends on the number before.
Good. If you look at what's up here, you have a formula, but the formula to get a term says, hey, use the, do you guys remember if the placement is n minus 1? What term are they talking about? To find the third term, a sub 3, you got to use the a sub 2. You got to use the term before.
Oh, that's
And sometimes it's a couple terms before, like the Fibonacci sequence, where you have to use 2 terms before, not just the one prior. So question, how does this one work? Where does it say to start?
first 4 terms.
Where does it say to start?
First 4 terms.
Okay, good. So what's the first term?
A sub
3.
Whoa.
A sub 1 is equal to 3.
Wait.
It doesn't say that n equal, well, okay, what we were defining here, I said that n could equal 0 or 1, but from the description here, since it did not define otherwise and says find the first 6, we started at 1.
So this does.
So we'll start at 1 again.
Does this, we're going to start.
So we're just having it start at 1, so this would be 3. What would be the next term?
2.
0.
This also says n greater than or equal to 2, which means we can't jump backwards, so I guess that would be the reason.
1.
You would start.
Isn't it 1?
So we go ahead and plug in and say, okay, so previous term, which is 3, to find a sub 2,
Can't
take a sub 1 minus 2, so that'd be 1.
Wait, how can you do 1 when n has to be greater than or equal to 2?
Wait, isn't it 1 less than?
Okay, so.
Okay, pause.
Oh.
Okay. This formula right here, this formula, is only true for n greater than or equal to 2. Why? Because at 1, we start with this value. So they define the first, and then they say, and then use this formula for every other term 2 and above.
Oh, okay.
So we're not going back to the 0th term, because they're not saying that's legal. They're saying,
Oh.
this is true, and to find anything A2 and above, go here. So we can't go back. And then Lucy, sorry, what was your question?
Isn't the first term we're plugging in 3 though, so,
Yeah. So 3 minus 2?
but isn't it like 1 minus 3, because it's saying a sub?
Oh, no, we're plugging in to find, this is my A sub first term, which they gave us. A sub second term, A sub 2 would be A sub 2 minus 1, A sub 1, take this guy, minus 2.
Alright, this makes sense.
And then to find A sub 3, we take A sub 2, 1, and then what's the pattern?
Minus
Subtract
2.
two.
Jumpity jump jump, negative 1. To find the fourth term, this is so easy. Negative 3. To find the fifth term.
Negative
To
5.
find the sixth term.
Negative 7.
Never.
Oh wait, we only have to find the first 4. 1, 2, 3, 4, good. And then what's it say? How?
Negative 11, right?
But you need.
2 ways. One way is to keep jumpity jump jump jumping and say, okay, well the fifth term would be negative 5, then negative 7, then negative 9, then negative 11. That's the 8th term. How? I jumpity jump jump jumped. The other way is to say, is there an explicit formula that I can make based on the numbers that I see for the first 4 that would then let me plug in 8 to solve?
Yeah.
Now, one way, some of you that are natural problem solvers might go playing with, can I make a formula in terms of n, where n, like this one, where n is the placement that'll give me the value. For instance, to get 3, when n equals 1, you could do n plus 2. But the problem is, n plus 2, 2 plus 1 is 3. If I go here, 2 plus 2 is not 1. Well, that didn't work. It worked for the first, but not for the
Wouldn't it be
second.
just 3 minus?
We could pause. I know some of you can jump to the right answer. I'm just giving a bit of the background. Another way to get to 3 is to say it's an odd number. And I could see, hey, all of these are going to be odd numbers. Now, if I do 2 times n, what kind of number will that always be?
A number.
2 times 1, 2 times 2, 2 times 3, 2 times 4. It'll always be an even number. 2n is a way to get evens. So how do we get odds?
3.
Start with an even. Well, 3n, 3, 6, 9, some of those are even, some are odds, and we're skipping ones.
Yeah.
But what I could do is start with an even number, 2n, and I could add 1 or subtract 1. Start with an even, add 1, you get to all the odds. So if I was to do 2n plus 1, 2 times 1 plus 1 is 3. 2 times 2 is 4 plus 1 is 5, going the wrong direction. How about 1 minus?
What the 3 minus 2n?
2n minus 1, what?
3 minus 2n.
That wouldn't work for the first one though.
For n greater than.
For n greater than or equal to 2, you could do that and start at the first one. You could do 3n minus, you could do 5n. No, not 5n, no, you don't want 3n. 2n, sorry. You have to have the evens, otherwise it's not going to work. Because 3n minus 2 would be 1, but then, sorry, would be 1. But then 3 times 3 is 9. 9 minus 2 will be 7. So we don't want 3n. We need that 2n. We need to go backwards. So we could do 1, 2, 3, 4, 5. 5 minus 2n. 5 minus 2 would be 3. 5 minus 4 would be 1. 5 minus 6 would be negative 1. There you go. 5 minus 2n. That would work. So you could come up with an a sub n I had to subtract evens because I needed the ever increasing to be negative. I needed it to make the entire expression negative. And I just figured out, okay, hey, who minus 2 times 1 will make me 3? Oh, 5. So then I could have also plugged in this way and said a to the 8 is equal to 5 minus 16, negative 11. Now, is this easy?
No.
No. Not for most. And for some sequences, if you're like, well, this one was easy for me, great. Other ones will be hard, I promise. Or maybe even impossible. However, what's the benefit of having an explicit formula, or even with an implicit one where the jumps are easy, making an explicit formula? What's the benefit? You can find the 100th, 37th, the 16th, and you can think of, ooh, the limit as n goes to infinity. Ooh. For whether the sequence converges, getting closer and closer and closer to a set constant or value, or diverges, gets ever increasing positive or ever increasing negative, aka ever increasing. Interesting. Let's keep going. Speaking of making nth term formulas, did anybody notice that the last sequence was actually a very basic one that we've covered before, called an arithmetic one, or arithmetic, as some people would like to make me say?
Mathematic.
Shouldn't arithmetic be anything? Just
Arithmetic.
anyway. This type of sequence, separated by commas, we talked about in pre-cal because it was like you're either adding a constant or subtracting a constant, and every single basic, fine arithmetic sequence, we could actually make pretty quickly an nth term formula by using the following clue. In order to go from A1 to A2 to A3 and beyond, we're always going to be adding a common difference. Which means to get to any sort of A sub n term, we could say that A sub n would come from the following. Starting at the very first, which is A sub 1, and adding however many necessary jumps of d to that original value. Now hold on. How many necessary jumps would there be for an nth term? Well, how many necessary jumps of adding d, or repetitions of addition by d, were needed for the third term? Only 2. You already had the first. To get to the third, you only need to take 2 steps, right? 2 additions. So to get to the third, you needed 2. To get to the 10th, you need 9. To get to the nth, you need n minus 1. So to get the explicit formula for any arithmetic sequence, we could just say, hey, it's the previous term plus d. That's great for little jumpity jumps, but if I want the 100th, heck no, I don't want that unless I use computer programming to make it faster. Sequence mode. Anyway. Or you can make a pretty quick nth term formula, an explicit formula that lets you jump right to where you want to go. So kids, number 13, what do you say? Go. Common difference, what's D? The 8th term, find me A sub 8. The implicit, the recursive, aka implicit, recursive, this is kind of a term that's used in programming a lot. Recursive, a type of formula or rule that depends on a previous solution in order to get the next, or a previous step to get the next one, the next step. AKA implicit rule, and then explicit rule. Implicit rule, you got one right there. Explicit rule, you got one right there. Shouldn't take us too long. Since I didn't get nutrition, I'm going to run back and grab myself some closing. Talk in your groups, help each other out. Some of you are just like randomly, I don't know what, giving up.
And what's the excuse?
Which one's?
You don't have a group. Look at you.
What's the recursive?
So we don't have a group. They're playing their
I just need to
No, we got it in our calculator.
Plug it in.
plug that in.
This is the table.
Yeah.
To find the income,
Yeah.
and able.
So C, me doing B just solves C. So
I still wanna ask you how much you do.
Yeah.
then, what's the explicit?
George, we abstracted by.
That's not what you gave us.
I've never done this one.
Yeah.
So which one's recursive and which one's explicit?
I have
Recursive, implicit.
Wait, but then isn't that just what?
I still remember.
Implicit meaning, in this case, means the next
Georgie would drive. Georgie would drive, so then like the rate that he charges might have to go a little bit lower. Since
What a nice.
it's an idea. Yeah.
Just confirm. Did you ever talk to the clown that came out of sewer? Also, side note, don't you think the original too big to fit into that sewer until it could be? There was nothing to him.
The recursive rule for, with the, this is the recursive one.
So if you're, he just takes on the first time, he's actually superior universe.
Each term became recursively.
I'm too lazy to find out what
Isn't that the recursive one is implicit.
Oh yeah, implicit, and then. Recursive is the one where you have A and minus
Explicit
one.
basically the only I'm falling out of the previous term.
I think that's because why would it ask you for the eighth term and then ask you to write the sixth? Because like that was either one of them. It would probably have the eighth term.
I love this term. This day it's so cold. Are we allowed to bring blankets to school?
Isn't it pretty warm in here?
Oh no, yeah, it's warm in here, and I'm very comfortable. I'm just thinking